Hello, Ghana Math Olympians. I am one of your instructors for the summer. My name is Mathew Crawford, and I'm here to create a first video. We're going to discuss a problem that was posted on the message board and some various tactics that we can use to approach problems like this. So here's the problem. The sum of two numbers is 1, and their product is also 1. Find the sum of their cubes. And before we go straight at this problem, we're actually going to take a look at a couple of easier versions of problems like this and talk about the tactics that we can use. So here's another similar problem. The sum of two numbers is 8, and their product is 9. Find the sum of the squares of these two numbers. So, the first thing that we're going to do is let's turn the words into math. The sum of two numbers is 8. I'm going to give the numbers names. Let's call them x and y. X plus y equals 8, and xy equals 9. And from here, we look for our algebraic methods that we might employ. And two methods we're going to go after, described very basically, are substitution and manipulation. And so much of algebra is one of these two things anyway, and so it makes sense that we would take a look here first. But now I'm going to copy my system of equations here. And let's try method 1 first. Let's try substitution. Let's take a look. All right, we've got a sum of x and y is 8, and the product is 9. And here's what I'm going to do. I'm going to get rid of one of the variables through substitution. I'm going to isolate y. Y equals 8 minus x. And we subtract x from both sides of that equation. And then I'm going to plug this in to the second equation so that only x remains. Instead of x times y, we're going to have x times 8 minus x, and that equals to 9. And let's go ahead and multiply this out and see what we get. And we'll move everything over to one side of the equation. And I'm going to go ahead and switch sides because my brain works better when the equation is on the left-hand side. So there are a number of things that we can do here. We can use the quadratic formula. I'm actually just going to go ahead and add 7 to both sides to complete the square, just because it seems easy enough to do so. And I also like to remind myself that the quadratic formula comes from completing the square. So x minus 4 is plus or minus the square root of 7. So x is 4 plus or minus the square root of 7. Okay, and so what is it that we wanted to do? We wanted to find the sum of the squares of these two numbers. And sure, and by the way, we can check. It's good to plug things back in and check your work. The sum of these two numbers certainly is 8. And when we multiply 4 plus the square root of 7 times 4 minus the square root of 7, we do indeed get 9. We can do that through a difference of squares. But we want a sum of squares here. We want x squared plus y squared. And by the way, if x is one of these numbers right here, y is the other. And you can verify that by plugging back into our substitution equation up here. So what can we do now? Well, we want the sum of the squares of x and y. Well, and x is 4 plus the square root of 7, y is 4 minus the square root of 7, and vice versa. So in some order, these are what we're talking about. And if we expand each one, we get 23 plus 8 root 7. And then we get 23 minus 8 root 7. And so our answer is 46. So substitution, always a good method. Not always good. Well, very often a good method when we're facing a system of equations like we face here, especially when we have a sum of variables in at least one of the equations. So now let's take a look at a second methodology. And this is the one that we're going to apply to the original problem. We're going to deal with something called symmetric sums here. As it turns out, well, I'll go ahead and we will port our writing of the equations here. And notice that these are both symmetric sums. And here's what I mean by that. If you swap x and y, you get the same thing. So these expressions are symmetric in that sense. Also, the expression that we're trying to find, which is x squared plus y squared, that is also symmetric. Well, turns out that we can create symmetric expressions out of symmetric expressions very often, and that kind of makes sense, since we should be able to swap the variables however we want with our building blocks, and we'll see what I mean right here. Let's think about how it is we get to squares. We get there most easily by squaring that first equation, but we may have to do a little work. Let's see what we get. We square the first equation, we get x squared plus 2xy plus y squared equals 64. Oh, well, great. We have an x squared and a y squared, but we also have something that we don't really want, we don't need, which is 2xy. But lo and behold, we can now make use of our second equation. If we multiply that equation by 2, we get 2xy equals 18. Now we subtract. X squared plus y squared equals 46. And we have our same answer again. And look at how little work we had to do to get there. We had to be clever. We had to think about how we could construct, and it was a multi-step construction. We had to think about how we could construct the sum of squares, but ultimately it was not all that difficult. And there are a lot of things that there are a lot of expressions like this. Once you get the hang of this tool, it'll make a lot of these problems very easy. And in fact, let's do something other than x squared plus y squared. What if we needed to find 1 over x plus 1 over y? Well, we could rewrite that. We could find a common denominator. We could rewrite this as x plus y over xy. Oh, and look, we have exactly the values from the two equations above. Or if we wanted to find 1 over x squared plus 1 over y squared, that would be equal to x squared plus y squared over x squared y squared. And that would be, well, we know that x squared plus y squared is 46. But I'm going to go ahead and write this out as x plus y squared minus 2xy over xy squared. And now you can see, if you hadn't done the previous part, you can see from the beginning that what we want is 8 squared minus 2 times 9 over 9 squared, which is 46 over 81. Now let's take a look at one more example, and then we're going to go back to the original problem. Sorry, actually I have 2 more examples. Pardon. Here's the first example 2. Here we go. X plus y equals 7, and x squared plus y squared is 17. Find the value of xy. So this is interesting. This time we're given a different set of information, and it's the product that we want. Well, x plus y equals 7. And I'm going to call xy, I'm going to call that p for a moment. P for product. And what I see is that if I square this equation right here, we already know this, we've done this before. If I square this, I'm going to get something that has the sum of the squares. It's also going to have twice this right here. And so if we want, we can substitute. Well, let's go ahead and manipulate this. And we know that x squared plus y squared is 17. And then we have 2 times the product xy. Actually, I'm not going to bother with this substitution. I sometimes do, sometimes don't. And we have 17 plus 2xy is 49. So 2xy equals 32. And x times y equals 16. And there's our answer. So yeah, you can, once you create the relationships between various symmetric expressions, you can go one way or you can go the other way. You just have to get used to it, practice these types of problems a little bit, and the manipulations involved, and you're going to have it. Now here is example 3, and this one is more complicated because we have 3 variables instead of 2, and really this makes substitution a whole lot more difficult, right? Well, let's take a look. What can we do to get a squared plus b squared plus c squared? And as we've seen before, the most reasonable start is to square an equation like that, where we have just the individual variables, and we know we're going to have an a squared, a b squared, and a c squared, but we're going to have other terms. Okay, so what do we get when we expand a plus b plus c? Well, squared. Well, we have a multiplied by a multiplied by b, a multiplied by c, b times a, b times b, b times c, c times a, c times b, and c times c. And as you can see, that's 3 times 3 different products. I'm a big fan of counting while I do my algebra, just to make sure that I have the right numbers of terms and the correct coefficients. So when we add all that up, we wind up with a squared plus b squared plus c squared plus 2 times the products of the 3 variables taken 2 at a time. And on the right-hand side of the equation, we simply have 400. So now we see on the left-hand side, we can go ahead and substitute. Oops, wrong one. Oh, that's the one we're trying to find. Pardon. We can substitute. I'll go ahead and regroup. What we've got is a squared plus b squared plus c squared plus 2 times ab plus bc plus ca, and that equals 400. Now we can substitute right here. And wow, turns out that a squared plus b squared plus c squared equals 0. And if that seems a little bit strange, it may be because you're imagining real numbers, but it turns out that there are no real number solutions to the system of equations. There are solutions, but there are only solutions in complex numbers, as it turns out. And if you're not familiar with complex numbers yet, that's a good topic to look up, and maybe I'll make a video on those later. But now that we have these tactics, let's go ahead and take a look back at the original problem that brought us on this journey. Here it is. The sum of 2 numbers is 1, and their product is also 1. Find the sum of their cubes. Okay, let's go ahead and start by turning the words into math. We'll call these numbers a and b. A plus b equals 1, and a times b also equals 1. Now, in order to get a sum of cubes, what I'm going to do is cube the first equation. If I cube the first equation and expand the left-hand side, I get the a cubed and b cubed terms that we want, but we have this other stuff in the middle, and we need to deal with that other stuff. Here's that other stuff. And what I'm going to do is just kind of on the side, I'm going to examine this. I'm going to factor it. We have a common factor of 3 and of a and of b, And when we factor those out, what remains is a plus b. Oh, that's nice. We know what ab is. And we know what a plus b is. Oh, so this is all just 3. Now we can substitute that into our equation. And we get a cubed plus 3 plus b cubed equals 1. So a cubed plus b cubed is -2. I hope you enjoyed this video. Let me know if this works for you. And I hope to make a number of these videos to help with the training process and to help with other students. I'm going to put this up on YouTube, on my YouTube channel, and hopefully a lot of people can enjoy and benefit from it. And we're going to try to get better at creating these videos. Thanks for watching.